Hello, welcome for our science lesson. In the previous lesson we were looking at the volcanicity and earthquake, and you remember what we had mentioned about volcanicity. We handled various extrusive features of volcanicity. After we had learned there are two types of volcanicity, that is intrusive volcanicity and extrusive volcanicity. In the previous lesson we looked at the extrusive volcanicity, and we learned that there are landforms which have been formed and they have been exposed on Earth's surface. And as a result of that, they lead to the formation of various landforms on Earth's surface that can be easily visible with our naked eyes. Today we are going to look at the intrusive features, and as we look on the intrusive features under these, we are going to base on the intrusive landforms. Occasionally when volcanicity occurs, we learn that there is sometimes magma that extrude itself into the bedding planes of the rocks. It embeds itself within the earth crust, and as a result of that, it leads to the formation of the intrusive landforms. These are landforms that have been formed within the bedding planes of the earth crust. Therefore, there are various features that we are going to look on and how they are formed throughout this lesson. When we look at some of the features that have been formed, especially when we base on the rock that has been melted, especially magma. We were looking at the magma. When magma melts, it is in its molten state. When magma melts, when it is in its molten state, it will be able to cool and solidifies to form some rocks. When magma cools, it will solidify and then form some solid rocks. These masses of rocks, sometimes they lead to the formation of the features beneath the bedding planes of the crust. And remember, the rocks which are formed by the cooling process of magma within the crust, these features are called the platonic rocks. We call them the platonic rocks, which can also be referred to as intrusive features. We can call them intrusive features or intrusive landforms. The intrusive landforms, especially when we look at the volcanic activity, the volcanicity is the one that gives rise to these intrusive landforms. Such landforms are various, and we shall be able to shortlist them here as we look at them one by one. One of the intrusive landforms include the batholith. We have the batholith. If they are many, we call them batholiths. And then we also have Laccolith. We also have Lapoliths. We have the Lapoliths. We have the Facolite. Call them the Facolite. And given time, we have Dikes. Dikes are part of it, and also seals. We have various features that have been formed as a result of the intrusive landforms, And these features include the batholiths, we have the laccoliths, we also have lapoliths, we have the phacolites, we have the dikes and sill, among other features. We are going to look at various stages of these features and how they are formed. To some given extent, we shall be illustrating on how they look like so that we are able to comprehend and understand. Let's begin with the first one, that is the batholith. We are going to look at a batholith and how is a batholith formed. Batholiths are large rock masses which have been formed due to the cooling down and solidification of the hot magma inside the earth, and they only appear on the surface after they have been exposed to denudation or weathering. You remember we covered the lesson on weathering in the previous time. Therefore, the weathering processes and also erosion is the one that removes the overlying materials that is covering the crustal rocks. As a result of that, it exposes the features which have been formed within the bedding planes of the crust, and as a result of that, it exposes the batholith on Earth's surface and therefore lead to its formation. But how is a batholith formed? A batholith is formed when the hot magma cools. When the hot magma cools and solidifies in the process of solidification. In the process of solidification, as it solidifies, under the process we call it solidification, it also cools, and then it leads to the formation of the solid materials that is going to be formed within the bedding planes. Within the bedding planes of the crustal rocks. Within the crust. Therefore, when the hot magma cools, it solidifies in the process of solidification, and therefore it cools and therefore compacts to form the solid rock, which is a mass that will be found within the bedding planes of the crustal rocks within the crust. Therefore, after a period of time, it will be exposed by weathering and erosion processes, leading to the exposure of a huge rock mass that we refer to it as a batholith. When it is within the bedding planes, it forms a certain feature, and this is how it looks like when batholiths are formed within the bedding planes, especially the core. Sometimes it has some huge mountain and may be exposed on the surface after the erosion and form some given features such as the granitic tores. This is how that looks like. I will try to demonstrate using this diagram. It looks like a huge mass of rocks that is emanating within the magma chamber of the bedding planes, and as a result of that, it is exposed within the earth crust, and in the bedding planes, this is how that huge mass of a batholith may look like within the bedding planes of the crustal rocks. And when it is formed, in the process of it being formed, you'll find that there are various layers of the earth crust that have been embedded. You remember the earth structure is made up of various layers within the crust, and these layers are just remaining within the earth crust. And therefore, this is the point of the magma chamber where the magma originates. This is where we have the magma. We call it magma chamber. That is the magma chamber. And then we look at various bedding planes of the earth crust. Remember, the earth crust is made up of different layers. You may be able to remember those different layers of the earth crust. And therefore, when this landform, we call it batholith, being formed in the process, it will cool and solidifies within the bedding planes. This is a representation of the crustal layers of the bedding planes of the earth crust, and eventually lead to a formation of what we call the batholith. This is the batholith itself. This is how it looked like. When magma is trying to find a crevice or a fissure, when it is formed, you will find that it is exposed on the earth's surface only by weathering or denudation process. When magma tried to find a crevices or a crack during volcanic activity, the magma, the hot magma, may force itself into the bedding planes. These are the bedding planes. The bedding planes of the crustal rocks. Just in other words, they are the layers of the crustal rocks, and therefore when magma goes into these bedding planes, it will cool and solidify within these bedding planes. Therefore, it is not exposed on the earth crust. It will not be exposed on earth crust unless it is actually exposed by the process of weathering and denudation. And therefore, in the process, it will lead to the formation of such a feature that is going to be formed within the bedding planes of the crustal rocks. Such feature looks like a huge mass of rocks that have been cooled and solidified within the bedding planes. We call it a batholith. And therefore, as a result of this, a batholith may look like this. To some given areas, it covers huge and extensive large surface, even to around 20 or even 50 kilometers, depending on the magnitude of volcanicity that has occurred in particular region. And we have various examples. I will mention one example of a batholith that has been formed in some regions of the world. We call it Adon Hue. Adon Hue is an example they are called Eidon Hills. They are found in Scotland. Therefore, we call them the Eidon Hills of the Scottish. Already that one have been exposed on Earth's surface. Therefore, we refer to them as hills. When they are still within the bedding planes of the Earth crust, we refer to them as a batholith. Therefore, an example is found in the Scottish border of the USA. It is formed as a result of this. And therefore, this looks like a batholith. We will move to the next one. Is referred to as a Laccolith. A Laccolith. That is the second intrusive feature. We refer to it as a Laccolith. Therefore, Laccolith are also large dome-shaped intrusive bodies which have been connected by a pipe like a conduit that is formed below the earth crust, with which they are intrusive counterpart of the actually the batholith, because it looks like a batholith, but most of them are formed in a given magnitude. Therefore, Laccolith are formed and they look like a dome-shaped feature of intrusive magma that have been solidified, cooled, and has been found within the bedding planes of the earth crust, and therefore it leads to the formation of such a feature we refer to as a Laccolith. They carry this shape that I will always refer to it. They have a large domed shape. That is a dome shape like. A dome shape like intrusion. Of magma which have been solidified which has been cooled and solidified, been formed and solidified within the bedding planes or within the crust or rocks within the crust. As a result of that, they have a dome shape like intrusion of magma which has been cooled and solidified within the crust. And simply a good diagram will be able to help us to this is how it looks like. During volcanic eruption, magma will try to be extruded into the earth crust. This is just a layer of the bedding rocks within the earth crust. And as a result of that, when magma tries to eject itself within the bedding planes, it goes, cools, and it is solidified within the bedding planes that is found within the earth crust, and therefore leading to the formation of a dome-shaped mass of intrusion of magma that is referred to as a Laccolith. And this is the earth crust. Therefore, this is a feature that can best describe how a Laccolith looks like and how it is formed. Remember, it is within the bedding planes of the earth. As a result of that, the bedding planes still continue to be formed. We have always to indicate the bedding planes because it is an intrusive feature that has been formed in this process. When magma cools, solidifies itself within the bedding planes, it leads to the formation of a large dome shaped like an intrusion of magma, which has been cooled, solidified within the crust of rocks or the bedding planes of the earth, and therefore forming a huge mass of an intrusion we refer to it as a Laccolith. This is how a Laccolith look like, and it is formed in this process. Remember, it is volcanicity is the one that which propagate the formation of such a feature, because the magma has been ejected into the earth crust, leading to the formation of such features upon cooling and solidification. And we have examples of such feature is found in Karakata Plateau. That one is in the border of India. It is found in Karataka Plateau on the border of India. This is an example of a Laccolith that I will give. It is found in India. This one leads to the formation of the granitic or the granite upon it being exposed on the surface of the earth as after the process of weathering and the process of the process of erosion. It leads to the formation. And we also have another example that is found, we call it Mount Malanje. It's found in Malawi. Malawi is found in Africa. This one is found in Malawi. Malawi is found in Africa. And then this one is found in the Indian border between the Deccan Plateau, where we'll be able to see such an intrusive feature that we refer to it as a Laccolith. We will move to the third feature of intrusive volcanicity, and that one we call it a Laccolith. We have a Laccolith. Is also another type of intrusive feature, and this one is formed when the lava moves upward in a piston or in a portion of the same projected magnitude of the vent, and that one it may extend up more in a horizontal direction, and as a result of that whenever it finds the weak planes within the earth crust, it may get rested within the bedding planes. And this one will lead to the formation of a saucer-shaped or a concave shape like a feature of an intrusion that is referred to it as a Laccolith. Therefore, basically, it takes a saucer-shaped, or you may also say a concave shape. It is a concave shaped intrusion. A concave shaped intrusion of magma or lava that is cooled within the earth crust and extend to a large direction, that is taking a horizontal direction, taking a horizontal large direction of horizontal wave, when it takes a horizontal wave in the bedding planes, the bedding planes of the crust or rocks. Therefore, when we look at it, basically it has either a saucer or a concave shaped intrusion of magma that is cooled within the earth crust, and it extends on a large direction of a horizontal wave in the bedding planes of the crust or rocks, now leading to the formation of a saucer-shaped feature. It is a saucer-shaped feature, shaped like feature or shaped like intrusion fonts. Thank you. It will lead to the formation of the saucer-shaped like feature of a landform that we refer to it as a Laccolith. I'll be able to illustrate that using a diagram so that we could be able to find it easy. Now, when we look at such a feature, it indicates a Laccolith, and how it is formed, we have already seen. This one takes a shape of a saucer, and therefore we referred to it as a Laccolith because it is still found within the bedding planes of the crustal rocks. As a result of that, it has that formation. And it may extend when it takes a horizontal direction. It may extend up to a large wave leading to a huge saucer-shaped intrusion of magma that we refer to it as a Laccolith. This one is how it looks like. In the process, it looks like this, and therefore this is how its diagram indicates. Therefore, we'll also be able to look at we also have an example that is found in Africa. We call it the Great Dike of Zimbabwe. The best example, we have the Great Dike. It is the Great Dike. When it is exposed on Earth's surface, it is referred to as a Great Dike. And this one is found in Zimbabwe. We'll also be able to look at Laccolith, how it is formed. Then we move to the seal as a feature number 4. We also have a Laccolith. We have a Laccolith, and a Laccolith is formed when a wavy mass of intrusive rocks, at times they are found at the base of the synclines of the folded igneous rocks. We shall look at folded igneous rocks later, but such materials have a definite conduit to the source that is beneath from the magma chamber and subsequently developed into what we call a Laccolith. We shall be able to look at that one, how it is formed. It is formed when a wavy mass, this one is formed it is formed when a wavy mass of intrusive rocks are found at the base. They are found at the base of the syncline. And synclines of the folded rocks the base of the syncline of the folded igneous rock, and such material will develop beneath and it will be develop beneath the earth crust develop beneath the earth crust and form within the magma chambers. It is formed within the magma chambers and subsequently lead to the formation of Laccolith. Shall be able to find its diagram and summarize it together when we look at sills and also dike. Let's move to number 5 feature, and that one is a sill. We have a feature that is known as a sill or sills when they are many. This one is a solidified horizontal layer of magma, especially inside. It is found inside the earth, and it is formed when the lava cools and solidify in the horizontal plane within the thickness of the material. Actually, if the material is too thick, it will form a slender and a very long or a prolonged intrusion. But when it is still too huge, it will form a huge tunnel of a sill, and as a result of that, it will lead to the formation of a thicker forms of sill, and sometimes they look like horizontal tunnels that have been laid underground within the bedding planes of the earth crust. And we'll be able to look at it when I demonstrate this diagram here, and then we'll be able to find it, because majorly it is found within the bedding planes of the earth crust. Therefore, this is a formation of a sill, and actually when you look at it, it takes a horizontal tunnel. Therefore, it is resting within the bedding planes of the crustal rocks. And you look at it, it is a horizontal solidified intrusion This horizontal layer, solidified layer of magma the horizontal solidified layer of magma inside the earth crust. Inside the earth crust. This is how it looks like, and in the process of the formation you'll find that this takes a horizontal solidified layer of magma that is found inside the earth crust. Remember, this one is the layers of the earth crust, or you can also call it the earth surface. When it is formed, it takes this shape, and in the process it may even extend to a larger distance and form into a horizontal tunnel that is found within the bedding planes of the earth crust, and therefore forming a simple feature that we refer to it as a sill. We'll be able to look at another feature, that is number 6, is a dike. Let's look at the dike. We have a feature that is known as also dike. Dike is also one of the intrusive feature that is formed when lava make its way through the cracks and fissures during volcanicity, and this one may develop into the land or the earth crust and then forming a vertical conduit that is perpendicular to the ground, resulting to the formation of a dike. When you look carefully at a dike, you'll be able to find out that if it is too huge, depending on the magnitude of the volcanicity, it will lead to the formation of a huge pillar of a dike-like feature. When it is exposed on the earth's surface by the process of weathering and erosion, it will lead to the formation of a pillar that you'll find it positioned and developed into a wall-like structure that is also called a dike. And we shall be able to look at an example. I will just mention it and then we'll look at it. It is called the Kaap Valley. Is found in the Kaap Valley in South Africa, and it takes the shape of a vertical intrusion, or a wall-like structure that may found itself standing within the bedding planes of the earth crust. Now, in the magma chamber, when the magma finds itself through the intrusion and the fissure, it may find a vertical or the perpendicular position where it is almost ejected onto the earth surface, but it is not already on the earth surface. It just cools, solidifies, and within the bedding planes of the earth crust, therefore leading to the formation of a wall-like structure that will stand within the bedding planes of the earth crust, that is referred to that is also referred to it as a dike. It is one of the intrusive feature that may develop, and we have an example is found in the it is found in the Cape Valley, especially in South Africa. It is found in the Cape Valley of South Africa. That is an example of the dike. This has been identified and recognized in the world, and they are mostly found in the intrusive forms of Maharashtra area, which are considered to be most feeders of eruption that has led into development of the Deccan Plateau or the Deccan traps, especially in the sides of India, bordering the Philippines, and also the other areas where volcanicity is very much intensive. We shall look at the regions of the volcanic, the regions of volcanic prone areas, as we will be able to cite this feature. Therefore, this is a feature that is known as the dike. We have been able to look at various features, intrusive features that have been formed as a result of volcanicity leading to their formation. One, we have been able to look at the batholith. We have looked at how a batholith is. We have been able also to look at Laccolith and how it looks like and how it's formed. We have been able to look also at the Laccolith. We also have Faccolith, and then sills and dike. I would like to summarize it in a huge diagram that will summarize all the features and also be able to look at the formation of the other features that may result as a result of the volcanicity in the process. Therefore, the features can be summarized in this diagram. When you look at it, it's a dissection of the section of the earth crust leading to the formation of both intrusive features and extrusive features. Extrusive features looks like the lava plateau, volcanic neck, and this is a caldera or a crater. This is a volcanic neck, this is a volcanic hill, and then this is a composite volcano. They are on the surface, we call them extrusive features. But when we come within the bedding planes, we have the Laccolith. You can now know what is this. You can quickly remember this one is referred to as a Laccolith. When you look at this one looks like it is a dike. And then this diagram here, this one indicates it is a seal. Both this one and this one is a seal. And then beneath it, this leads to the formation of a batholith. When you look at it, it is a summarized diagram of all both the extrusive features and the intrusive features of volcanicity, and it leads to the formation of various features. Now, after looking at these features, what is their significance? Because you've been able to look at extrusive along the way, the extrusive and intrusive features. Do they have any significance on the physical environment? Do they have any significance on the physical environment? We'll be able to look at the various significance of the volcanicity at large, and then we will have been able to look at both the extrusive features and the intrusive features. When we combine to them during volcanic activity, there are some features that are going to be formed on Earth's surface. We call them the extrusive features, and also the ones that are formed within the earth crust are referred to as intrusive features. They lead to the positive and negative effects. They have both positive and negative effects on the physical environment. When you look at the positive effect of volcanicity, you will find that the volcanic eruption has produced high volcanic mountains in the highlands, which can easily be seen on the earth's surface, and therefore after erosion they result into the formation of the volcanic soils. They lead to the formation of the volcanic soils. Now, this is something that is found on Earth's surface. Does soil has any significance? Indeed, volcanic soil that are formed as a result of volcanicity, they are fertile, they are rich in volcanic ash. Therefore, they can be used for agricultural practice. Therefore, this is the area where crops can be grown, such as wheat, barley, and also some other agricultural products that can be found because of the volcanic soil. At the same time, when you look at various volcanic features, they lead to the formation of the beautiful scenery. They make scenes. Their scenes are very much beautiful, and they attract people who like the nature, and in forms of the people may come in various countries. They are attracted. We call them the tourists. And when the tourist flocks in some different areas, in different regions of the country, for the purpose of just looking the scenic or the features that are found on Earth's surface. Therefore, they bring to the country what we call the regional foreign exchange, and therefore they lead to the improvement of the GDP of that country. At the same time, when volcanic eruption happens, they expose minerals. When you look at this feature, it is showing that there is magma that is being ejected almost within the bedding planes. Now, during the volcanic eruption, the mineral that could have been found at this point, specifically at this point, will be extruded forcefully onto the Earth's surface, and during the lava flows, we'll be able to find some minerals are found on the Earth's surface, and therefore as a result, they expose this mineral on Earth's surface and making extraction of minerals like diamond, gold, and even gemstones can become very much easily mined because they are at the disposal. They cannot incur technological advancement. That is much of it as a positive. When also you look at the volcanic mountains, we have volcanic hills which are highlands. Some of them on the leeward side of this mountain, there is some features of the arid which are formed. They are also attractive scenes. But on the windward side of those hills, there is plenty of rainfall. Because when rainfall appears on the windward slopes of the mountains, you look at, there will be various vegetation such as forests will become also a catchment area of water. We can find them forming a catchment area of water in form of rivers. And rivers can be very much useful. Rivers can be very much useful to the formation of these features, and therefore one of the important of rivers is that they lead to the generation of hydroelectric power that can be supplied in the regions. In the next lesson, we'll be able to look at the negative effects and part of the positive effect of volcanicity on Earth's surface, and therefore we'll be able to have found a better impact on our physical environment in terms of volcanicity. Have a good day. Thank you. We'll stop.